Cyclic alkenes, also called cycloalkanes, are the basic name for these is ring structures. They have rings like here. You see they have 3-membered ring, 4, 5, 6, 7, etc. Of course, you can't begin with anything less than 3. There's only 2 carbons. So these ring structures, or cyclic alkenes, cycloalkanes, they use very similar rules. But you use the prefix cyclo before the name of the alkane. So when we had 3 before, it was propane. Now we call it cyclopropane. Cyclopropane. 4, it was butane. Now we call it cyclobutane. Cyclo Pentane, cyclohexane, cycloheptane, etc. The names are very similar. Of course, when I say similar, there are tiny differences, like the cyclo. You go with the prefix, the same thing, where the substituents are, and what are they, the parent hydrocarbon, how big is the ring, and then, of course, the suffix. If you have an alcohol, you have to include the "ol." So let's start with the first example. What is the parent cycloalkane? Well, it's very apparent. It's this 6-membered ring. Six carbons, that's cyclohexane. Part 2 says, or Rule 2 says, no number is needed to indicate the location of a single substituent. So if you have a single substituent right here, there's no need for you to actually indicate or include that number. So all you have to know now is that what substituent is this? And if you recall, this is an ethyl. So if we have an ethyl and it's occurring at 1, 2, 3, 4, 5, and 6, all we have to call this is ethyl cyclohexane. Notice we did not include 1. What's the point of including 1? It's kind of like saying 1x. No, we say x. So that's the idea, is that it's implied that there is a substituent at that first carbon. Well, what if you have 2 or more substituents? Then you have to number the substituents the same way you did. And of course, you have to start with the 1 that's in terms of alphabetical order and go to the next, keeping in mind that the next one has to get the smaller number, or as small as possible. So in this case, you have that's 5-membered ring. So that's a cyclopentane. You have 2 methyl groups. It doesn't matter where you number them from here. They're both methyl groups, so we could number them 1. But where you start is important, and where you go next. So if you go down here, you will give this next methyl a 4. But if you go up, so if you go counterclockwise, you will give it a 3. Clockwise, you would get a 4. So this is how you should number it, lower numbers. So in this case, we have 2 methyl groups. In this case, you have a 1 and a 3. So you do have to include now the 1 as a frame of reference. So we say 1, 3 dimethyl cyclopentane. Now we have an alcohol. So we number this way, 1. We go 2, 3, 4, 5, and 6. And the reason why I went is because OH has to get the lowest number. You might say, well, what about this? This comes from an ether, so it's a substituent. We're going to look it up in a second. But again, this has to get the lowest numbers. What do you have? You have methyls. And you might, of course, understand why we're going this way rather than the other way, because we want the smallest numbers possible. So in this case, 1, 2, 3 versus 1, 2, 3, 4. Then you start counting at the 5 and the 6. So that's what's wrong here. So these are methyl groups. And let's look up what that one over here. Very well. This right here is called a methoxy. A methoxy. A methoxy. It's an oxygen, of course, attached to a CH3. That's called a methoxy. Denotes an ether. If you have 2, then that would be called an ethoxy. If you have 3, that would be called a propoxy. If you have this attached to an isopropyl here, it would be called an isopropoxy, etc. That's really the difference. So in this case, we have a methoxy. So be careful in the alphabetization here. This should be named first because methoxy is M-E-T-H, not a fancy word. O, here you have a Y. So therefore, this is first. So you have 3-methoxy, 2,2-dimethyl. And of course, we do not have to include the 1 because the hexanol, cyclohexanol is implied that the OH is at 1. Cyclohexanol. All right, let me write it under here. Cyclohexanol. Oh, cyclohexanol. There's one last thing I want to end with here, is that some students may ask, well, what if I have a long chain and I have a ring? Which one would be the parent hydrocarbon? It's whatever one is longer, which one has the more carbons. So if the number of carbons in the ring is greater than the number or equal to the number of carbons in the longest chain, the compound is named as a cycloalkane, If there are more carbons in the chain, then the compound is named as an alkane. Very well, let's look at this. Here in this one, we have a ring that has 1, 2, 3, 4, 5. So those are 5 carbons, and that would be a cyclo pentane. So it's 5 carbons. So the ring has 5 carbons in it. But if I look at the long chain of carbons, this would give me 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. That would give me 10. So there I have a decane. And that's 10 carbons. So then I go with 10 carbons. And this would become a substituent. So this is now a substituent that I told you is that any substituent, alkyl substituent, is the same name except you replace the ending with a YL. So that becomes a cyclopentyl. Sorry about that here. Cyclopentyl. Now, if it was the other way around, then of course the chain would be your parent hydrocarbon. In this case, we name this as you have 2 methyl groups and you have a cyclopentyl. Cyclo is alphabetized. That occurs at 5. So you say 5 cyclo pentyl 3,7 dimethyl decane. So these are the substituents. In terms of rings, can be substituents, methyls, etc.